it is actually possible to convert a term that has an exponent that is a rational number, like 2/3, into something that is a radical, even whenever it's not something like 1/2, 1/3, 1/4. So if this was 64 to the 1/3 power, it would just be the cubed root of 64. But this is 64 to the 2/3 power. Now, you may be smarter than me, and you're able to remember um, how to do this without needing some kind of cutesy little trick. But when I first learned how to do this, way back in the olden days, I had so much trouble remembering when you have a rational exponent like this, which one is the index, which one is the root. So if it's 64 to the 2/3 power, is it a square root because of the 2, or is it a cubed root because of the 3? So it's either going to be the square root of 64 to the third power, or it's going to be the cubed root of 64 to the second power, and I could never remember which is which. So my teacher, when I learned this, taught me this really silly way to keep them straight, which I still remember to this day. He drew a tree, and he said, here's how you remember. In a tree, the roots of the tree are at the bottom. The roots are at the bottom of the tree. And so if you remember, roots are on the bottom, you will always be able to convert these properly. 64 to the 2/3 power, the 3 is on the bottom, so 3 is going to be the root. This is going to be a third or a cubed root. And then he said, the sun, of course, is at the top, and the sun is shining on the tree, and that's where the tree gets its power, is from the sun. So power on the top and roots on the bottom. And I know it's silly, but that's how I remember it to this day. I remember powers on the top because of the sun, and the roots on the tree are on the bottom. And so 64 to the 2/3 power is going to be a third root because the root is on the bottom. And it's the third root of 64 to the second power. Third root of 64 to the second power. So we could put this into the calculator in a couple of different ways. One of the ways that we could put it in the calculator is we could square 64 and then cube root it, but it might be easier to cube root 64, and then square it. We should have our cubes memorized up to 10 cubed, and so we know that the cubed root of 64 is 4. And 4 squared is 16. So the cubed root of 64 is 4, 4 squared is 16. So 64 to the 2/3 power is 16. Okay, so let's try another one. Let's try 36 to the 3/2 power. Okay, so the root is at the bottom. So this is going to be a square root. So it'll be the square root of 36 to the third power. Square root of 36 to the third power. And because we have our squares memorized all the way up to 25 squared, right? We memorized those. We know that the square root of 36 is 6. And so we do 6 to the third power. And because we have memorized our cubes up to 10, we don't need a calculator for this one either. 6 to the third power is 216. So 36 to the 3/2 power is 216. Now we can sort of do like a spot check of these answers. If we look at 64, the power that we're raising it to is less than 1. 2/3 is less than 1. If we did 64 to the first power, we would get 64. Since we're raising it to a power less than 1, we expect our answer to be less than 64, and it is. It was 16. With 36, the power we were raising it to was more than 1, so we expect our answer to be more than 36, and it is. It was 216. So that's another way we can sort of check ourselves at the end and at least see, does our answer make sense? Was our answer bigger than our original number, smaller than our original number, and then based on the exponent, should it have been? If our exponent fraction was smaller than 1, then our answer should be smaller than the base. And if our exponent was bigger than the original number, or bigger than 1, then our answer should be bigger than the original base. And so that's another way when we get to the end, we could sort of make sure, did we get the root in the right spot? For me, I just remember the tree. Thanks, Dr. Northcutt.